Hello, everyone. We are back again to our math journey. If you haven't yet subscribed, I'd like you to do us a favor by subscribing to our channel, Tutoring Made Easy. And we are always welcoming to comments and suggestions. So feel free to drop any comment that you have in the comment section. Maybe you have specific topics that you want us to do a video on. Feel free and share in the comment section. Today, we are going to look at a different topic altogether, and the topic is logarithm. The topic is logarithm, and logarithm was propounded. It was propounded by John. Was propounded by Napier. John Napier in the year 1614. In the year 1614. Now, logarithms are usually of the form. They are usually of the form. They have a certain form. If you look at, let's say, log b to the base a. All right. So usually we refer this to as, this one is the base. A there is known as the base. Yeah, the A is known as the base. Um, yeah, log b to the base a. So we pronounce it as, it's pronounced as log b to the base a. Log b to the base a. So if you have something like this, let's say we have log m to the base n, and we equate it to, let's say, x. What it means is that, remember, in index form is going to be, let's say, having the n, because we know that the n here is the base. So the base is the n, and then the x here is the exponent or power. So then that goes to the top of the n, because that's the exponent or power, and then it is equal to the m. So that, there you have it. So if, let's say that we have, let's say, log, log 8 to the base 2, and it's equal to x, we are going to write, this is the base, right? Don't forget that this is the base, and then this is the exponent. So we're going to have the base, which is 2, exponent x is equal to 8. 2 to the power of x is equal to 8. And then we take it from there. So far, we know that logarithm was propounded by a man named John Napier in the year 1614. And we said that logarithms are written in the form log b to the base a. The a there is the base. And usually, if there's an equal to sign there, the result is usually the exponent or the power. Exponent or the power. Today we are going to look at, let's quickly look at the laws. Let's look at the laws of logarithm. There are some laws of logarithm. So let's look at the laws of logarithm. So we're going to look at the laws. The first law there is that if you have the log 1, all right, log 1, and usually when we write a log, you know how I mentioned that if you have log b to the base a, this one is specific. This is the base a. But here, there's nothing here. The moment nothing is stated here, it is assumed. It is assumed to be in base 10. So usually when you are working in base 10, we don't really write it. So basically what we are saying is that if you have log 1, it is the same as writing log 1 to the base 10. But usually we don't do that. We don't do anything. Now the first law says that if you have log 1, it's always equal to 0. Now let's prove that. Let's look at the proof. Let's look at the proof of that. Now, log 1, since we don't know what is the answer, we'll equate it to be x. So that we have log 1 is equal to x. We have log 1 is equal to x because we don't know what the answer is. Now, we also know that this side is the base. The base here is 10 because it's nothing is stated there. And if we are in base 10, what it means is that we have to indicate the base. And the base there is 10. We write the base, and we said this is usually the exponent. So that's going to go into the on top of the base, which is 10. So that's going to be the exponent. So 10 exponent x is equal to 1. Now, 1 can be written as 10 to the power 0. Remember, in indices, we said any time you have a number raised to the power 0 is 1. So 1 is also the same as any number to the power 0. So since we have 1 here, we are expressing the 1 in terms of 10 to the power of 0 because of this 10 here. If we have 5 to the power of x is equal to 1, it will be 5 to the power of 0. All right, so that's why we chose 10 and not 1 million or anything. So let's say that let's say we have a million, or let's say 100 or 1,000 to the power of y, and then we have 1. We're going to write this 1 in terms of 1,000 to the power of 0. Okay, so let's have that in mind. Okay, so we are still on the proof. Now, since we have 1 to be 10 to the power of 0, and then can you see that this base and that base are equal? Since the two bases are equal and there's an equal to sign between, what I'm trying to say is we are having 10 to the power of x is equal to 10 to the power of 0. Since this base and that base are the same and there's an equal to sign in the middle, it means the exponents are the same. If the two bases are equal, then the exponents or power equal, right? So therefore we can say that therefore x is also equal to 0. So that's why we can say that log 1 is 0. All right. So we are going to write it very well. It's a bit clumsy, but the first law says that if you have log 1 is 0. Log 1 is 0. That's the first law. If you have log 1 is 0. Log 1, first law is log 1 is 0. And we looked at the proof. The proof says that we should make log 1 to be equal to x. And since here nothing is written in the base, we assume that that's base 10. So 10 to the power of x, because x is the exponent, is equal to 1. And we say 1 is the same as 10 to the power of 0. And since the bases are the same, base here is equal, and there's an equal to sign in the middle, therefore x is 0. It implies that log 1, which is equal to x, is 0. Therefore, log 1 is 0. So that's the first law. That's our first law. Now, the second law, let's look at the second law. It says if you have log AB, it's the same as log A plus log B. It says that if you have, second law says that if you have log AB, log of all AB, it is equal to log A plus log B. Now let's be careful. It's not the same thing. We're not saying that log. Not be careful. We're not saying log A times log B is the same as log A plus log B. No, it's not true. Not true. Look, don't forget, this is what we are looking at here. Log A times log B is different. It's different. It's different from log of AB. which we are talking about, which we are saying is the same as log A plus log B. So we need to be mindful of that law. Log of AB is the same as log A plus log B. All right. Also, let's be careful. Also, log of AB is not the same as log A times log B. It's wrong. It's wrong. Please, let's be mindful of that. Let's be mindful of that. Let's be mindful of that. So let's take an example. Let's say that I have log 8. I can write log 8 in terms of log 2, right? Log 4 times 2. Okay, so then this becomes what? A, and this becomes B. And this is the same as log AB. Then we can apply it, right? So we can have log 4 plus log 2. So let's have that in the back of our mind. Okay, log A plus log B. Log A plus log B. Log A plus log B. Now let's look at the third law. Let's look at the third law. Let's look at the third law. Sorry about that. Let's look at the third law. The third law says that if you have log of A divided by B, if you have log, third law says that if you have log of A divided by B, it is the same as log A minus log B. Okay, so that's a rule. Log A minus log B. Now, we are not saying it's the same thing as that. We're not saying it's this. Be careful. We're not saying log A divided by log B. It's wrong. It's not the same thing as log A over B. It's wrong. We're not saying log A divided by log B. It's not the same as log of A divided by B. They're not the same. So we need to be careful. So if we have something like, let's say, let's pick an example. Let's say we have log of 3 over 2. That's the same as log 3 minus log 2. If we have, let's say, log of 5 divided by log 2, please, it is not the same as log 5 minus log 2. It's wrong. This is wrong, please. Let's be careful. It's wrong. The only time this is going to work is if you have log of x divided by y. Then we know that that is log x minus log y. So let's keep that in mind. Let's keep that in mind. Now let's look at the fourth law. The fourth law, and then maybe we can end there. We can look at the fourth law, and then we can end here. So the fourth law says that if you have log of A to the power of n, it's the same thing as n, dropping the n at the back of the log A. So an example of that is, let's say I have log 8 to the power of 3. I have to drop the 3 behind the log 8. So don't forget this rule. This rule also works. This rule also works. So basically I can rewrite this as log 8 to the power of 3 is the same as log 2 to the power of 3, and I get log 2 to the power of 3 times 3, which is log 2 to the power of 9. Then I can now drop it 9 at the back of log 2. So that's how these are some of the few laws of logarithm that we are going to discuss today. When we come back again, we'll continue with the other laws. But if you haven't subscribed yet to our channel, please do us a favor by subscribing, liking the video, and sharing to as many people as possible. And we welcome as many comments and suggestions as possible. Maybe you have a specific topic you want us to look at. Feel free to drop it in the comment section below. All right, I'll come to you again. Please take care. Bye.